Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad FAKRUL Hidayat bin NAZRI. My metric number is 211293344. I'm from Group 2 RY31. Today I want to illustrate lab control system technology for lab 4, frequency response, plot by using MATLAB. In this lab, I perform the calculation for the task 1 and I get the answer for the question is 1 over 4s power 2 plus 4s plus 1. So I'm open the MATLAB and I transfer the transfer function from calculation to this MATLAB. For numerator, I place the number is 0, 0.1, and the number for denominator is 4, 410. And I'm using the function for A, so I'm want to check the transfer function I'm correct or not. Oh, I need to run first. So I want to check the transfer function I correct or not. So I put A here, and the transfer function I get same from my calculation. So from I run this simulation, this coding, I get this graph. In this graph, have a gain margin and pace margin. So I want to see the detail for this graph. Right click and characteristic and click on all stability margin. Can see this is for gain margin. The dB is 20 and the frequency is at the radian per second is 0.5. This loop is stable. And for the pace margin, the degree is at the 68.2. The delay margin in second is 12.3. The frequency is at radian per second is at 0.0964, and this loop is stable. Next, I will run for the next question. In the question, for the numerator is given is 300 and 300, and for the denominator is 1, 57, 360, 500, and 0. So when I run this simulation, I get this graph and show the characteristic of the stability margin, and we can see the gain margin for dB is 35, and the frequency is radian per second is at 70.5, and the loop is stable. For the pace margin, the degree is 96.9. The delay margin in second is 2.48. The frequency is 0.681. The loop is stable. Next, I will run for the in question. Next, I will run for the calculation when the k is 50 and the k is 500 and when the k is 1500. So I'm open the MATLAB and then from the calculation I get this numerator is 150 and 150. The denominator is same, and I run this simulation and show characteristic or all stability, and I get for the gain margin is 41 and frequency is 70.5, and this loop is stable. And for the pace margin, the degree is 94.5 and the delay margin is 5.32. The frequency is at 0.31 and this loop is stable. Next, I will run for the when the k is 500 and I get the value for the denominator is 1500 and 1500. The denominator is same. I will run this simulation and I get this graph, and for the gain margin this is 21. The frequency is 70.5 and this loop is stable. For the phase margin, the degree is 56.9. Delay margin is 0.234. The frequency is 4.24 and this loop is stable. And the last simulation, when the K is 1500, I get from the simulation is 4500 and 4500. The denominator is the same, and I will run the simulation. And for the characteristic and all stability margin, I get the gain margin is 11.5. The frequency is at 17.5 and this loop is stable. And for the base margin, the degree is 26.5. Delay margin is 0.0533. The frequency is at 8.68 and this loop is stable. That's all for lab 4. Thank you.